Hello, everybody. Hope you are doing great. Let me talk about two important terminologies. The first terminology that you daily uh, have to face, that is about distance. The distance is the length of the path, length of the path. How much path you cover, the total length is called the distance. This is the first thing. Secondly, distance is a scalar quantity. Why we call it a scalar quantity? Because it only need magnitude. Magnitude is the number with unit. That is, we have a number like you have 5 kilometer distance. Five is a number, kilometer is a distance. An object travels 2 centimeter or 50 meters, so number with the unit is required. So there is also very important thing that we know, that no need for the direction uh, for the distance. So whenever we are talking about distance, we can just simply say a distance or the length traveled. We can use unit. uh, the SI unit usually we use is the meter, but for the long distances, we use kilometers, we use miles, or for very small distances, we can use centimeter or meter. But please keep it in your mind whenever we are talking about distance in physics or in science, so we can use only meter as an SI unit. You know, SI unit is a unit that we uh, recognized is as universally known one particular unit. So we will use it as a proper unit. So we normally say meter is the proper unit for the distance. So whenever we are going to calculate distance, we need to talk about how much total length of the path is being covered. Now coming back to the other point, there is another terminology that we also face in our daily life. That terminology is known as displacement. Whenever I use the word displacement, it refers with change in position. Displacement, it is number one. We use this as it is change in position. Change in position uh, is, for example, if an object is initially at point A, for example, you can say this is the initial position of an object, and it moves from position A to position B. So initial position, let's say I say x1, its final position is x2. So I will say it is final position and this is initial. So displacement is usually denoted by delta x. This terminology is the Greek terminology that is called delta. It is referred as change in. So now, when we are going to find displacement, it is delta x. That will be final position minus initial position. That is from the start point, that you can say xi and xf is much better to write it. So final position minus initial position, last point minus beginning point, the start point. Okay, whenever I am going to find the change in position, I need to move from start point till the end point in a straight line path. So it means it has a direction. So we can say that it is vector quantity, vector, because it has length, the magnitude. You can also say the distance it has with the direction that is from start point to the end point. Okay, now whenever we need to find the displacement, as I said that it is a vector quantity, so I need to use frame of reference. What is a frame of reference? A frame of reference is usually one of the two. First of all, what is frame of reference? Frame of reference is the boundary or the region within which we find the measurement. So you can say region within which we are trying to, within which we are measuring the quantities like distance, displacement, all of these quantities. There are, as I told you, there are two basic types of frame of references that we can use. The first one that we can use is, we call it Cartesian. Cartesian in mathematics, you call a system or a plane in which you have vertical axis named as y-axis, a positive y-axis, negative y-axis, and horizontal is called positive x-axis and the negative x-axis, and the point where these two cross is called origin, and these are the planes within which an object is being placed or it is moving. And the other one that we usually use, um, if I remember, it was named as cardinal system. And in cardinal system, what do we have? Cardinal system, it's like in geography, what you use x-axis, y-axis as east, west, north, south. So we are having here the right side is considered east, left side is considered west, and then it comes to north, and then it comes to south. So these also used to show the direction for the, especially for the displacement, because displacement is a vector quantity. So now I get back to the point where I should talk about when we are going to understand these things. Let us have a quick review what we just discussed a little while ago. For example, we have an object that is moving its initial time t1 to the x-axis, that is Cartesian system. Its initial position is 10 meter, and the final position is it has, you can say it is 30 meter. So this is x1 is the start and x2 is the end point. So from start to the end point, this is we have. Okay, now from start to the end point, we have this situation. So the question says what we need to do is just match the columns for the best described value. For example, this term number one is representing the delta, and this is to show the what you called a Greek letter that is showing this. So I will match this one with this. Then delta x, that is equal to the displacement. So in this one, how to find displacement? I told you earlier on, delta x is the final position minus initial position, and you can say final position is 30, initial position is 10. So 30 minus 10, that is 20 meter. And you can say it is moving from here till here. So this is toward the east direction or toward the right direction or right side of the positive x-axis. So this one is going to be here. Now, the third one, displacement, by the definition, I just told you that displacement is change in position, and we can calculate the change whenever we divide final position minus initial. Cartesian coordinate system is the frame of reference. There is another one we just said as cardinal coordinate system. So Cartesian coordinate system and the cardinal coordinate system. So we have these two coordinate system. Let us do another simple practice for understanding more about what we talk about these distance and displacement. When we are going to talk about distance and displacement, we can just use this one. Like we have to imagine a person walking 70 meter to the east. When the person is walking 70 meter to the east, then what is happening to its motion? For example, this is the person that is walking to the east 70 meter and then walks back to the west 30 meter. So actually, when I'm going to mention the distance or displacement, I need to use the coordinate system. So here I am going to use a coordinate system for the understanding. Let's say I am using cardinal system here. So I can say this is to the east direction. Now the person walks from, this is the start point, and from this start point, person walks for here. You can say it is going to 70 meter to the east. And then it, from this point, it goes back and it is going to the west and it goes to 30 meter here. So it means this position, if this one, this point was 70, so this point, it is 30 meter west. So this point for me is the point of 40. So I can just simply say that this one is the east direction. Let me mark the points here. This is 70 and this is 30 meter back, it is 40. Now, the first part of the question is compare the distance. For the distance, I just told you it is total length of the path. So it was 70 meter. We don't care about the direction. 70 plus 30 meter is equal to 100 meter. And I am not going to mention any direction here. But when I will be asked to find displacement, so what I need to do for displacements, I need to find delta x. So for delta x, I need to find change in position. So change in position mean this is the start point, that is 0 point, and this is the end point, that is 40 point. So I can say final position is 40 meter and initial position is 0 meter. So I will say 40 meter, and you can see this is to the east direction. So 40 meter to the east. If I forgot by any way to represent this 40 meter, and how to I will represent, I will just draw this with the blue line. This is my displacement 40 meter to the east. If I forgot by any way to write east, it means it's wrong. It cannot be considered as correct. So I, for sure, I need to uh, write this one, what you call east direction. Without direction, it is useless. So please be sure whenever you are finding the displacement, we have to mention the direction. Without direction, displacement is zero. But for the what you call, but for the distance, we don't need to care about the direction because direction is not important for that. Okay, now let me get back to the point here. This is another example. An ant is moving from at x20. So first of all, when I will do this one, I need to mention the Cartesian system here, let's say, because it is using x and y. So this is y-axis, and here let's say this is x-axis positive and this may be x-axis negative. So this is 10 centimeter, 20, 30. So I can just mention 10, 20, 30, and this is displacement is showing in centimeters. And on this is 0, and then this is negative 10, negative 20, negative 30. So I will say negative 10, negative 20, negative 30. So ant is starting from 20, that is 20 centimeter. Let's say this is the starting point. So this is the starting point, and it walks along the paper along negative 20. So it goes to negative 20 here from 20 till negative 20. sorry for not being straight line, and then goes back to -10. From here, it goes back to -10. So now, this is the final position, and this is the initial position. Let us talk about the distance it travels. So total distance, I know that total length of the path. So from here, I will count. This is 1, 2, this is sorry, 10, 20, 30, and then again, I'm repeating, sorry, there is a mistake, 10, 20, 30, 40, and 50. So distance is, you can say, first 40 to the west and then 10 to the east. So you can say 50 meters. Sorry, it was meter. I just wrote it centimeter. So this is 50 meter. When I will talk about displacement, so what I need to do, as I told you earlier on, I need to know delta x by using initial and final position. For example, this is the initial point, this one is the start point, and this one is the end point. Start position xi, end position is xf. So delta x is xf minus xi. This shows that xf final position is -10 minus initial position is 20. So this is -10 minus 20. That gives -30. What does the -30 meter mean? That it is to the left, because right side is considered as positive, so left side is considered as negative. So I can say 30 meter, or I can say -30 meter, or I can say 30 meter to the left. So this will be very important to remember, 30 meter to the left, that is negative. Now, how I can draw this one? This was my starting point. I will start from here, and this is my end point. Now you can check that delta x is how much. It is from here till here. So this is 10, 20, and 30. So this is what we have to talk about. So I hope you guys understand, especially this last third example, and inshallah it will be easier for you. But please keep it in your mind, for displacement being a vector, we need to draw it, we need to mention the direction, and also we need to use the left, right, up, down, north, east, and also the vector arrow should have been used to show the result of the final answer. Thank you so much, and bye.